Hello students, today we are going to see some more interesting and important questions from Narendra Avasthi sir's physical chemistry, redox reaction. Come on, let us discuss few more questions from this session. The first question, a sample of pure sodium carbonate 0.318 gram is dissolved in water and titrated with HCl solution. A volume of 60 ml is required to reach the methyl orange endpoint. So calculate the molarity of the acid. So here titration has taken place, sodium carbonate versus HCl. Now sodium carbonate versus HCl means Na2CO3 plus HCl. It gives what it is, NaCl plus H2O plus CO2. So when we balance this equation, here Na2CO3, here NaCl, so here 2. So that means here also you will get 2, then 2 H2O and CO2. Right, here one oxygen has come. Okay, now it's balanced. So 1 mole of sodium carbonate requires 2 moles of HCl, right? So now number of moles we have to identify. So given mass, they have provided what it is, given mass of the sample sodium carbonate, it is 0.318 gram. Okay, now let us find out the number of moles of Na2CO3. Number of moles of Na2CO3. So that means here what it is, given mass by molecular mass. Now given mass by molecular mass, right? So given mass, how much it is? 0.318 gram. And molecular mass, how much? Here, what is the molecular mass of Na2CO3? It is 106 gram per mole, right? So here 106 gram per mole. So what is the answer you will be getting? You will be getting here. So the answer it is 0.003 moles, right? 3 moles you will be getting. Right, now the next one, moles of HCl from the equation. So moles of here 1 mole of sodium carbonate requires 2 moles of HCl. So moles of HCl from the balanced equation. Moles of HCl from balanced equation, that is stoichiometric. Okay, so that means here 2 moles required now. So 2 moles of HCl into moles of that is given mass and molecular mass. So here what we got, that is given mass, right? So given mass by molecular mass, that is the moles we have found out, right? So that is 0.003 moles. Right, so this HCl we don't know the moles, so molarity we have to identify. For that we are getting that moles from balanced equation. So balanced equation, what is it? How much HCl required for complete the reaction? 2 moles. 2 moles into number of moles of sodium carbonate. This is sodium carbonate moles. So you'll be getting what it is, 0.006 moles. Right, got it? Now we are coming to that molarity. Right, you got that idea how to go for it. So volume of the solution in the question, how much they have given? 60 ml. So volume of solution. Volume of solution they mentioned, to find that end point, add methyl orange they mentioned, So how much ml? Volume of solution 60 ml. You just converted to liter, 0.060 liter. Okay, now molarity is what it is, number of moles of solute divided by volume of solution in liter. Okay, so molarity equal to number of moles of solute divided by volume of solution in liter. Right, so you'll be getting what it is. So this is actually number of moles of the solute, right? Sodium carbonate only, right? So that means here what it is, 0.006 moles divided by volume of solution in liter. Just now we found, no, that is 0.060 liter. So molarity is what it is. Molarity is equal to 0.1. Molarity, it is 0.1. So in the question, what is the answer they have provided? In the question, let us check the option. So here, calculate the molarity of the HCl acid. So HCl acid, it is 0.1. I hope you got the clarity. So option A is the correct option. Got it? Come on, let's go to the next question. Next question, 10 liter of hard water required 5.6 gram of lime water for removing hardness. Hence, temporary hardness in ppm of CaCO3 is. Okay, now before explaining the sum, let me explain this points to be noted down for you. Right, hardness of water, that is having soluble salts of calcium and magnesium ions. And degree of hardness, how to identify? Degree of hardness is defined as the number of parts by mass of calcium carbonate or its equivalent quantities of other substance present in million parts of mass of water. So hardness of water is equal to mass of calcium carbonate by mass of water into 10 to the power of 6 ppm. Okay, come on, let us check the question how to identify the answer. So here CaHCO3, right, calcium bicarbonate with the lime CaO, it gives what it is, CaCO3 plus H2O. So CaCO3, it is a precipitate. Okay, now balancing equation here, CaHCO3, here CaO, so here 2 CaCO3. Okay, lime, the 10 liter of hot water required 5.6 gram of lime. 5.6 gram of lime, removing hardness. So here 1 mole of lime require you're getting 2 moles of calcium carbonate. Okay, now let us find that number of moles of lime over CaO, right? So number of moles of CaO, let us identify. So here 1 mole, here 2 moles, right? So number of moles of CaO, calcium oxide, that is also known as lime, right? So this is actually here. So given mass by molecular mass, no. So given mass by molecular mass. So given mass by molecular mass 5.6 gram, and the molecular mass of CaO, that is 56 gram per mole, right? So you will get what it is, 0.1 mole. So what is the mole of number of moles of CaO? It is 0.1 mole. Okay, now we have to find out the hardness of water, degree of hardness of water. So how to identify? So here I just mentioned number of moles. I just raise the size. Okay, number of moles of CaO equal to 0.1 mole. Right. Now the next point, what it is, number of moles of calcium carbonate you have to identify. Number of moles of calcium carbonate. So that is actually here number of moles equal to what it is, according to the balanced equation. So balanced equation, how do we identify? Here 1 mole of lime and 1 mole of calcium bicarbonate, you are receiving what it is, 2 moles of calcium carbonate. So that means here 1 mole of calcium oxide requires to give that calcium carbonate, 2 moles of calcium carbonate we are receiving. So number of moles of CaO, that is number of moles of CaO, it is actually what it is, 0.1. So number of moles of calcium carbonate, according to the balanced equation, it is 2 moles. So that means here 0.1 into 2, you will get 0.2 mole. So 0.2 mole, it is what it is, number of moles of calcium carbonate. Yes, found. Okay, now given mass of calcium carbonate, we have to identify. So given mass of calcium carbonate. So given mass, how to identify? Number of moles of calcium carbonate into what it is, molecular mass of CaCO3. Got it? So here what you will give, so here number of moles of calcium carbonate, just now we found, that is from the balanced equation along with that number of moles of HCl, so CaO, so you will get what it is, 0.2, you are getting 0.2 into molecular mass of calcium carbonate, you know very well, that is 100, your marks in chemistry, that is the way you remember. So 100 gram per mole. So here that means what is the answer you will be getting? Given mass of calcium carbonate, it is 20 gram of calcium carbonate, it is 20. Okay, now we have to find out the density. Okay, density equal to what it is, mass by volume. Okay, now mass of water we have to identify. So mass of water, what it is, mass of water we did not know. So mass of water equal to density into volume. So in this point here, mass of water equal to what it is, density into volume. So density, how much? Density, it is actually what it is, 1 gram per ml into volume of water, it is 1 liter. So we can mention it as 1000 ml. Right, 1000 ml into 10 liter. In the question it has mentioned 10 liter, right? 10 liter they mentioned, no. So altogether when we are calculating, you will get what it is, 10,000 milliliter. That is in the gram. Here the mass of water only they mentioned, no. What mass of water, that is density into volume, no. So here 10,000, no. So 10,000 means what it is, 10 to the power of 4, can we write it? So 10 to the power of 4 gram, because mass of water, no, 10 to the power of 4 gram. Okay, now hardness of water. Now only we just mentioned hardness of water. What is the formula? So hardness of water. So hardness of water, mass of calcium carbonate divided by mass of water. Mass of calcium carbonate. In the question we have found, no, divided by mass of water. You just check into 10 to the power of 6 ppm. You just check it in the points to be noted down. I have given one formula. Just check it. See here, hardness of water, mass of calcium carbonate divided by mass of water into 10 to the power of 6 ppm. Right, got it? So apply the values. Mass of water, how much? Mass of calcium carbonate, how much? Mass of calcium carbonate, it is 20. Mass of water, 10 to the power of 4 grams into 10 to the power of 6. Okay, so let us apply the value here. 20 gram divided by 10 to the power of 4 gram into 10 to the power of 6 parts per million, right? So you will get how much? So you will be getting, I just mentioned here, 20 into 10 to the power of 6 into 10 to the power of minus 4 when it goes upwards. Minus 4, no? So you will be getting around what it is, 2000 ppm, parts per million, Right now you got that idea. How do we go for it? So here 1 mole, actually 1 mole of calcium oxide can provide 2 moles of calcium carbonate. So according to that point, let us go for the review for this question. So number of moles of calcium oxide, that is 0.1 mole, and then number of moles of calcium carbonate, according to the balanced equation, it is 2 moles. So both we get answer 2 moles, then 0.2 mole. Then given mass of calcium carbonate, we got it through that, and mass of water through density, we got this point. And finally we are receiving what it is, that formula, it is hardness of water to find out. So hardness of water only they are asking in the question. So hardness of water equal to mass of calcium carbonate by mass of water into 10 to the power of 6 ppm. So you will be getting answer what it is, 2000 ppm. I hope you got a very good clarity about this question. Come on, let's go to the next question. What is the option? Option B, it is 2000. So answer it is B, it is 2000. Yes. Question: 1 liter of pond water contains 20 milligram of calcium 2 plus ion and 12 milligram of magnesium 2 plus ions. What is the volume of 2N Na2CO3 solution required to soften 5 liter, that is 5000 liter of pond water? So as I mentioned, the same points I just wanted to mention again. So the hardness of water, how do we dissolve that? So it is soluble salts of calcium and magnesium ions. That is when we are adding what it is, calcium hydroxide or lime. So when we add, automatically it will be soluble. Right now the next point, hardness of water, how do we identify hardness of water? Equal to mass of calcium carbonate divided by mass of water into 10 to the power of 6, that is parts per million. So you will get, okay, now here bicarbonates, as I mentioned here, now bicarbonates of Ca2 plus and Mg2 plus ions, when we add calcium hydroxide or lime, CaO, when we add, you will get that what it is, that dissolved solution. Then you will get calcium carbonate plus magnesium carbonate. That is we get as a precipitate. So you will get as a precipitate, right? Okay, now in this you have to identify what it is, calcium carbonate, magnesium carbonate. They have given all those ideas. So here that means Ca2 plus and Mg2 plus. Right now Na2CO3 bicarbonates, the carbonate or bicarbonates when we are adding, so you will get what it is, CaCO3 plus here what it is, MgCO3. Right now here milli equivalent you have to identify, equivalent of so and so you have to identify. So milli equivalent, here milligrams only they have given no, so ml they have given no. So milli equivalent of Ca2 plus milli equivalent of Mg2 plus equal to milli equivalent of what it is, milli equivalent of Na2CO3, right? Solution, that's what they mentioned, Okay, now valency factor for both this one and this one, valency factor N equal to 2. So that means here milli equivalent of calcium, let us find out. So milli equivalent of Ca2 plus ion, right? So that is actually Ca2 plus how much gram they mentioned. So given mass by molecular mass into N factor. So that is calcium 20, no? So 20, that is given mass 20 milligram divided by molecular mass of calcium, it is 40 gram per mole into valency factor, N factor, valency factor, right? So this is actually what it is, 2, right? So this is given mass, molecular mass and N factor. I just mentioned the formula also side by side so that it will be easy for you to understand into, right? So you will be getting around what it is, you'll be getting 1, it is actually here what it is 2. So that means here 1 milli equivalent, right, of calcium ion. So now we have to find out magnesium also same, you will get, see, milli equivalent of magnesium ion Mg2 plus. So given mass by molecular mass into N factor. So given mass how much here, 12 milligram, right? In the question here we get 12 milligram. So you will get 12 milligram divided by molecular mass of magnesium, it is 24 here milligram, no? Yeah, here milligram here 24 here gram per mole into N factor here also 2. So here also you will get 1 milli equivalent. Now total milli equivalent of calcium and magnesium, right? Total milli equivalent of equivalent per liter. Okay, total milli equivalent per liter. So what it is, this is one magnesium 1 and calcium 1. So you will get what it is, 2 milli equivalent per liter. Okay, now next one, milli equivalent of sodium carbonate you have to identify. So milli equivalent of sodium carbonate. So milli equivalent of sodium carbonate how much? Normality into volume in liter. So normality how much in the question it has mentioned 2N, and volume in liter how much they mentioned 2N Na2CO3 required 1 liter of 2N Na2CO3 as needed to soften okay, soften 1 liter of pond water. 1 liter of pond water. Right now here, so total volume of that is total volume of liter required to complete that 5000 liter they mentioned, so total volume equal to 1 ml divided by 1 liter into 5000 liter. That is what they mentioned, 5000 liter. So that means here 1000 ml equal to 1 liter. So that ml equal to 1 liter. So that means 5000 ml. Like as we are getting the answer, so it is 5 liter. So that 5 liter. Now let us check the answer here. Now the answer it is, yeah, 5 liter answer is available. Yes, the answer it is 5 liter. I hope you got the clarity about this question and this trick also. Please remember this trick. Yes, come on, let's go to the next question. 1 liter of sample of hard water contain 4.44 milligram of calcium chloride and 1.9 milligram of magnesium chloride. What is the total hardness in terms of ppm of calcium carbonate? See, this is very simple. To find out that each hardness, actually it is equivalent mass of calcium carbonate we have to identify. So find out the total hardness. Right now, mass of the same idea, just to bring it because related points now. So first thing, molar mass of calcium carbonate, molar mass of calcium chloride, molar mass of magnesium chloride, everything we can find out. Then finally we can go for hardness of water of calcium carbonate, right? Molar mass of calcium chloride. So molar mass of calcium chloride, it is 111. Please remember 3 ones. Okay, 111. Sometimes we cannot go and identify each and everything during examination time. You please remember all these simple tricks. Okay, so this is gram per mole, and molar mass of magnesium chloride, MgCl2. So this is actually what it is, 95 gram per mole. Right now, calcium carbonate, you know very well. That is your chemistry mark, right? What is it? Molar mass of CaCO3, 100 gram per mole. So sometimes you please remember related points in that way. Yes, I wanted to get that mark of what it is, 100 in that chemistry. So that is molar mass of calcium carbonate. In that way also you can bring that, right? Okay, so hardness of water, hardness of calcium carbonate, hardness of calcium carbonate. So hardness of calcium carbonate given moles of salt divided by molecular mass of salt into what it is, molar mass of calcium carbonate. Okay, given mass of salt, right, divided by molar mass of salt, molar mass of salt into what it is, molecular mass of calcium carbonate, right? Okay, now let us apply the value for each. So first thing, calcium carbonate, calcium chloride, now CaCl2. So that means here what it is, 4.44 gram divided by molar mass of salt, 111 gram per mole into molar mass of calcium carbonate, gram per mole. So what is the answer you will be getting? You will be getting around 3.96 milligram. Right. Next one, MgCO3. MgCl2. So MgCl2, here also the same. Given mass how much? Here, actually here milligram, no, I just mentioned gram. That's what I was wondering. What is this here? Milligram, how is it? Yeah, here milligram, no, in the question it has mentioned milligram. Right, here milligram. Right, now the same point. See here, 1.9 milligram divided by, here what it is, 95 gram per mole into 100 gram per mole. Right, now here what it is, 2 milligram, 0.00 milligram. Right, this gram and gram will be cancelled, mole will be cancelled, milligram remaining. So that is what's each thing we cannot tell. So you should understand all this. So this is calcium carbonate, calcium chloride. This is magnesium chloride, and the next one what it is. Now total hardness. Total hardness of calcium carbonate, right? 3.96 milligram plus 2.00 milligram. So altogether 5.96 milligram total hardness. So total hardness of what? Here, what is the answer? Total hardness of calcium carbonate in ppm. So you will be getting around 5.96 milligram of ppm only. So this is actually calcium carbonate. So approximately it is 6 ppm. ppm only we are mentioning. So it is given in that ppm only. Like milligram, it's ppm only. So what is the answer? You can bring that here. Option D, it is 6 ppm. Right? Okay, come on, let's go to the next question.